Let's keep getting warmed up for calculus. In this video, there's two things I want to take a look at. First of all, we want to factor certain types of polynomials and look at trig functions. Now, the types of polynomials that I want to look at factoring are those that can be factored by grouping. And so when we look at f of x is equal to x cubed minus 3x squared plus 5x minus 15, we can group this polynomial into two separate groups. In the first one, we got x cubed minus 3x. And so out of that part, I'm going to just factor out an x squared. And I'll be left with x minus 3. Then, for the second part, where we have plus 5x minus 15, the common factor is that positive 5. And when I factor that out, I'm left with x minus 3. Now, I hope that you notice that out of each of these terms, we have this common factor of x minus 3. Since that's a common factor between the front half and the back half, we can factor that out in front. And what we're left with is that x squared plus 5. Now that I have the function written as f of x is equal to x minus 3 times x squared plus 5, we can identify all the zeros of the function. Because remember, a 0 is what's going to make this thing equal to 0. And that will happen when x is equal to 3 or when x squared is equal to negative 5. So that will be at plus or minus square root of 5i. Of course, you learned about all that in Algebra 2, the use of complex numbers. In calculus here, we're not going to use that too terribly much. But one that you will see that's a little bit tricky is a polynomial that looks like this when we have x squared plus 7x minus a squared minus 7a. Now this looks like we can split it in halves. Again, in the front half, we can factor out an x, and we'll be left with x plus 7. On the back half, we can factor out a negative a, and we'll be left with a minus 7. Now, there's a lot of similarities there, but when we look at each term, this term and this term, they don't share any common factors. So this process hasn't helped us out very much. That's because we haven't done the key step first. And our key step is going to be to rearrange this polynomial so that we have those quote-unquote like terms next to each other. Now what I mean by that is the rearranging, since I'm going to start with an x squared, I want that a squared to be right next to it. Then I'll have 7x minus 7a. Now, when we split this polynomial into two halves, front half and back half, and we factor on the front side, that's the difference of two squares. So x plus a and x minus a. On the back half, when we have 7x minus 7a, there's a common factor of 7, and we're left with x minus a. Again, we still have two terms, this term, and they both share a common factor of that x minus a. So the x minus a is what I'm going to factor out in front. All right, so I'm going to take that x minus a, bring it out, along with this one, and they're both sitting in this spot. What we're left with is x plus a plus 7. When you do your homework, I definitely want to see you rearrange this polynomial before you start factoring it by parts. When it comes to remembering the values of sine, cosine, and tangent of our most important angles, lots of teachers have tried lots of things to help get you to remember it. One of the things that I've used, didn't use it in pre-calculus last year, but I've used it in Algebra 2, is the radian snowman, or this unit circle. If you remember, each of the points on the unit circle represent a different angle in radians. So when we start at 0 over here and work our way counterclockwise around the circle. So if we made one entire loop around the circle, that would be 2 pi radians. So if I only went halfway, that's pi radians. If I only went a quarter of the way, That's pi over 2. So we had 0, a half of a pi, 1 pi, and then down at the bottom would be 1.5 pi's, and then back to 2 pi's. And we can keep dividing up the circle. These would be my pi over 4 angles, and here we have pi over 6 and pi over 3. And those points or coordinates on the unit circle represented cosine and sine. All right, so whenever we talked about any ordered pair, it was going to be the cosine of an angle and the sine of the angle are the two coordinates. So if I were to look at this point right here, at pi over 6, we could draw in this right triangle. Since we're dealing with the unit circle, it has a radius of 1, so the hypotenuse of that triangle is 1, making the vertical side 1/2, and Pythagorean theorem would make this root 3 over 2. So the ordered pair, the x-coordinate is root 3 over 2, and the y-coordinate is 1/2. Just so happens that cosine of our angle, theta, being the central angle right here, is going to be adjacent over hypotenuse. And sine is going to be opposite over hypotenuse. And that's how we'll get those two coordinates for the ordered pair. With pi over 4, it was root 2 over 2 and root 2 over 2. And when it came to pi over 3, since pi over 6 is 30 degrees, pi over 3 is 60 degrees, and it switches the x's and the y around. So we're at 1/2 and root 3 over 2. And as we proceed around the unit circle, that pattern would continue, and we just have to pay attention to positives and negatives. So as a refresher, let's walk around the unit circle a little bit, finding sine, cosines, and tangents. If we're looking at pi over 6, make sure you recognize where that angle is. Then we can see that the x-coordinate is longer than the y-coordinate. Every point is going to be cosine, sine. So remember that. So the x-coordinate is going to be the root 3 over 2 on pi over 6. So cosine of pi over 6 is root 3 over 2. The sine would be 1/2. Then when we find tangent, tangent is sine over cosine. So 1/2 over 1, or over square root 3 over 2. And the over 2's cancel, so this is 1 over root 3, which is root 3 over 3. When we look at pi over 3, this one, now the central angle is the pi over 3, or the 60 degrees. Same triangle, it's just the x and y coordinates are switched around. So now our cosine is going to be 1/2, and our sine is going to be root 3 over 2. Okay. Since tangent is sine over cosine, root 3 over 2 over 1/2. The over 2's cancel, and we're just left with root 3. The last one is the pi over 4 angle. This one in the middle. Pi over 4 is important because that's the 45, 45, 90 triangle where the base and the height are the same. And those are going to be the root 2 over 2's, which makes our tangent root 2 over 2 over root 2 over 2. Everything cancels, and that will equal 1. Now, as we move out of the first quadrant, we're going to keep those same angle measures and those trig values in mind, but we just have to pay attention to whether it's going to be positive or negative. So when I'm looking at the sine of 3 pi over 4, first of all, think about which quadrant that's in. Pi over 4 was in the first quadrant. That's 1/4 of pi. So we started at 0. There's a 1/4 pi, a 1/2 pi, 3/4 pi is going to be right here. Which means the angle we're talking about is this one. The sine, we have to determine what the value is at is going to be. Sine of 3 pi over 4, since it's a pi over 4 angle, sine and cosine are both the same. They're both root 2 over 2. But we have to pay attention. Should it be positive or negative? Now remember, every ordered pair is cosine, sine. Right? So the x-coordinate is cosine, y-coordinate is sine. When I'm looking at 3 pi over 4 being in the second quadrant, to get there, we have to go back, so the x-coordinate is negative, and the y-coordinate is going to be positive. The y-coordinate is sine, so our sine of 3 pi over 4 is going to be at positive root 2 over 2. When it comes to 7 pi over 6, we got to think about where that is. And 7/6 is more than 1. So if we started at 0 and we went halfway around the circle, there's 1 pi right here. Right? So we need to go past pi by 1/6, which would bring us to the next spot. So here's where 7 pi over 6 is. Cosine is the x-coordinate, so we got to go back here to get to 7 pi over 6, meaning cosine is going to be negative, and it's the longer one, so it's negative root 3 over 2. When it comes to tangent, tangent is going to be the ratio of sine and cosine. So that's sine of 300 over cosine of 300. Well, where's 300? Thinking about our angles in terms of degrees, our pi was 180 degrees, so if we go 90 degrees past that, 270 is right here, and so we need another 30 degrees to get to 300. Now remember, that doesn't mean that 300 is, the same as a 30-degree angle, because it's what it makes with the x-axis. So this acts exactly like the pi over 3 angle, the 60-degree angle. Right? To get there, remember cosine and sine. Our sine is longer, so sine is the root 3 over 2. Since it went down, that's a negative root 3 over 2. And our cosine is the shorter side, so that's a half. And because it went to the right, that's a positive 1/2. Now when we simplify the entire fraction, we're left with negative square root 3 over 2. This is meant to be a refresher as you practice these in your homework. Do them how you learn them, or whatever feels good for you. When you're in class, I could show you some other ways to go about it, by drawing triangles or using the left-hand trick, which is really nice. So practice and ask questions.